Hey, hi, this is Vikas. My topic is on today is deep learning on computer vision. And nowadays, like you can see, the computer vision is a field like of a that can be expanded like very rapidly. For the artificial intelligence nowadays, most of the things are being made for the artificial intelligence to reduce the manpower. So the man feels of need a vision, right, to get a clarification on the things what they are doing. So one of the such examples is like a face recognition is one of the popular thing you can see in every app. And nowadays the monitors is been adopting the same system for the more security rising purpose. Like they're using the example like you can recognize the faces and you can increase authentication. And the Apple is the one of the most popular thing introduced the face recognition before by unlocking the smartphones. And like we when as like like different lot of examples, like any system that can be like from its environment, suppose like you can take for any ways for the deep learning, so it can take appropriate action. So sometimes like human computers is one of the way to understand the world through the pictures. When we given a picture that can be like example that we uncleared picture can be recognized with a clear thing. And you can show me that, I can show you the next slide. And coming to the one of the concepts in the field of computer vision is like to visual like the perceptions as like the world perception is a main task is even known as just the one of eve. And you can go with yes, you can go with like different things, considering like self-driving vehicles as I said before, and like developing them. And the role of the computer vision is like is not to just compare like a surroundings, but also like predictions, the way it works, the way it works like signals and turning into it and etc. And using these inputs like we can like successful like inputs like when we go for the signal, how can they can like a car can be prediction the stop sign board like by like recognizing the its images and capturing and getting into like a different classifications inside it. And you can see like so you're like in the fourth ppt fourth slide, like where the input is being given as the image of the blur, and you can go with the output with an extra or with a better quality than the input one. So like like it is a early stage like a computerization is like a simple one, like where the images are processing, consideration like on computer vision where now image has been processing to just a part of computer visions. And the image is processing just to a part of part of a computer like to build and vision systems. There are mainly considerations of two types of inputs, like you can see here like a one is like a device like gathering the images of the like difficult task, when we are like when we are using like cameras as the sensing devices. And so when we use the cameras as sensing device, they get a capture. And even the phone has been like you can see that this opticalizing sensor nowadays is being predicting. And this can be also used for optical for the 3D, for taking the picture from the 3D, that they introduced like a 3D pictures in the online shopping with Amazon. So everything is been developing by day by like for the computer visions. And when coming to the having like neural networks like ANN, and that can be works for the brain neurals as ANN helping the interrupting the devices. And the each bit of the image known as like a pixel as a passer through like a neuros. And you can go for the slice there like a deep learning like is effective compared to the non-proper domain knowledges. And in the real world we doesn't have like knowledge, like learning applying the knowledges and gaining the predicting the output. We cannot predict like 100% output will be. And but like now by passing to the NNN clusters you can get like a maximum output. Like deep learning is the best option to implement in a computer vision. And the second thing is neural networks. Like it coming to neural networks, like it teaches us like data same how to teach our brain, like it's the same as like works as a brain functional for the it's a brain key for them to artificial intelligence, like neural network human brains as in surround like interacted for each other, and it's a processing of. And in the same way neural network has like passed data from one to other, right? It can be passing from one to other. And you can getting like informations from the previous things. And coming to the like next thing, like what is the advantages? We have like a multi lot of advantages, and we do have some few disadvantages too in the vision, like coming to the neural networks, like you can discuss on like how the neural networks is like beneficial, compared to the machine learning algorithms. And one of the benefit is like traditional machine learning algorithm to the feature extractions, and you need networks to the neurons to the can act as a both features like extraction and declassification. And for the classification features from the image and classify them into like to the labels, in a basic concept for for any neural network, we can use like prescriptions, like you can see here, like prescription, like the neural network, how the works it all, because so when you pass like a w0 is equal to 1, or like w1 is equal to 0, w is equal to n is equal to is of or done. So the prediction plus tasks like input calculates the, so we can put the step activation functions and predictions to the output, like we can get like by these using these type of algorithms, or like we using these type of calculations, we can get a perfect outputs. And coming to the coming to the like multi-layer prescription, this plays one of the key roles in the like in the artificial intelligence, like when we're dealing with like a complex problems, like when like multiple prescriptions, like for the neural networks. And in input layer, like it contains like how like features of a vector, and that's one of the things. And hidden layer, the hidden layer, like in which layer we won't have any control input or output to the neuron, which it doesn't, like we don't have like any features for. And its output layer is like any different, it's just gathering the information, and like where it could be real output of set of like like probabilities, like which building like any deep learning models, and which can we set the number of layers on a hyperparameters, and like these are the in the main things in the multi-layer prediction neural networks. And when due to the like some advantage, some advantage continually learning from like patterns of abstraction, like features by itself, like deep learning plays like a virtual role in any real world like applications, like self-driving vehicles, which is built using like self-driving and computer visions too. And these are the main multi advantages, like and coming to the the input layer and the hidden layers here, and it comes, you can see the clear picture here, like we can be like hidden layers, how the input layer is coming into the c1 coming to the a1, and x1 is going to the, so there are the multiple, and you can see the final the output, the which is the internal working on process going on, and the final output from the internal to the hidden, and everything the passes to, and it come for the a1 and the a2. And this is the main conclusion, like it's going to like due to some advantages continuous learning from the patterns, extracting features by itself, the deep learning is a virtual role computerized to applications like self-driving cars, the best example, like but they are also using the same thing, which is the sponsored things more than that, like neural networks and ann and cnn patterns. And they have been like using like implementationing, so. And that's it for the, and thanks for this opportunity, and thank you so much. That will be done.